In the beginning, the world seemed simple. Apples fell, planets turned, the heavens obeyed the language of gravity. For centuries, this was enough. A universe of predictable motion, a cosmic clock wound by unseen hands. But beneath that clockwork surface, something restless stirred, tiny sparks of mystery, flickers that refused to obey the rules of ordinary sight. Invisible forces whispered across space, binding matter in ways no eye could see. Electric currents, magnetic pulls, and fields that stretched like ghostly veils across the void. At the turn of the 20th century, the search for truth slipped beneath the surface of the visible. Physicists peered into the atom and found not a solid stone, but a storm. A nucleus wrapped in emptiness. Particles that came and went like shadows. Forces that held the world together with threads finer than light. Each discovery unraveled the old certainty, and in its place arose a stranger vision, a universe woven from the unseen. Here, matter dissolves into energy. Here, solidity is an illusion. Here, the cosmos is not built of things, but of patterns, vibrations, and invisible bonds. This is the story of that hidden scaffolding, of particles that never rest, of fields that fill the void, of forces that bind galaxies and human breath alike. It is the story of the invisible web, the secret architecture of reality itself. The universe begins in silence, not the silence of absence, but the silence of a stage prepared before the curtain rises, a darkness so vast it seems hollow, an emptiness so endless it seems barren. Yet what appears as void is no emptiness at all. Between the blazing furnaces of stars and the drifting orbits of planets lies an unseen ocean. It does not shimmer, nor cast shadows, yet it carries every breath of existence. The space between atoms, the gulf between galaxies, all of it filled with a hidden architecture. This is the invisible web, not woven of stone or steel, but of vibrations and fleeting sparks, particles born in the depths of quantum fields, threads that stretch across creation, holding the smallest quark to the widest cluster of galaxies in an unseen embrace. What seems solid is not. Every wall, every mountain, every human hand is a lattice of ghosts bound by silent forces. Reality is not carved from certainty, but stitched together by whispers that no eye can see. The cosmos stands upon a scaffolding of particles that appear only in their passing, a fragile grid that keeps the world from dissolving into nothing. And so the question lingers like an echo across eternity. What is this hidden lattice? This trembling foundation of the real? What unseen web binds galaxies in their spirals and holds the human body together with the same invisible breath? What is the secret architecture of existence itself? In the closing years of the 19th century, the universe still appeared simple in its design. Matter was thought to be continuous, like a smooth fabric stretched across space, governed by Newton's equations of motion and the invisible pull of gravity. The world was mechanical, predictable, a clockwork cosmos in which every piece of matter was a cog, every orbit a gear, and every motion the consequence of a law written long ago. But beneath the surface of this reassuring order, cracks had begun to form. A new kind of vision was needed, one that could peer beyond the limits of sight and into the hidden architecture of the very small. It was in 1897 that J. Thomson, working with cathode rays in a laboratory clouded by faint green glows, discovered the electron. What had once been imagined as indivisible atoms, the unbreakable bricks of matter, now revealed themselves to be far from solid. They contained smaller fragments, charged particles that danced through space like sparks torn from a storm. For the first time, the atom was not the end of the story, but the beginning of a deeper mystery. In 1911, Ernest Rutherford, firing streams of alpha particles at thin sheets of gold, uncovered yet another secret. The atom was not a solid sphere, but an expanse of emptiness. with almost all its mass packed into a tiny central nucleus. The rest was space, a void so vast that if an atom were the size of a cathedral, its nucleus would be a grain of dust floating at the center. The illusion of solidity was unraveling. The early explorers of the microscopic world had opened a door into realms that defied intuition. What appeared solid and unyielding was in truth a fragile constellation of charges and voids. The atom, once thought indivisible, was now revealed as a miniature cosmos of its own, governed by hidden forces that could not be touched or seen. In this hidden realm, new laws were needed. Classical physics, with its elegant certainty, began to stumble. At the dawn of the 20th century, quantum mechanics emerged, a framework that replaced certainty with probability and replaced objects with waves that flickered between existence and absence. James Clerk Maxwell had already prepared the ground. His equations of electromagnetism, written in the mid-19th century, had revealed that electricity and magnetism were not separate mysteries, but two faces of the same invisible field, stretching across all of space. His work hinted at something profound, that forces were not transmitted through empty voids, but carried by unseen fields that bathed the entire cosmos. Now, quantum mechanics extended that vision. The electron was no longer a mere point of matter, but a ripple in an invisible sea, a quantum wave, at once everywhere and nowhere, collapsing into reality only when observed. And still, the story deepened. By the 1930s, another ghost joined, the cast, the neutrino. In 1930, Wolfgang Pauli proposed its existence as a desperate solution to a troubling puzzle. In radioactive decay, energy seemed to vanish, violating one of physics' most sacred laws. Pauli suggested that an invisible particle must be carrying the missing energy away, undetected. Enrico Fermi later gave this particle its name, the neutrino, the little neutral one. For decades, it remained a phantom, impossible to see, impossible to catch. Yet billions of them stream through every human body each second, without resistance, without sound, without leaving a trace. In the middle of the 20th century, the picture grew stranger still. The atom's nucleus, once thought indivisible, was discovered to be a cage of smaller particles. Protons and neutrons, in turn, were not elementary, but composed of even more fundamental entities, quarks. In the 1960s, Murray Gell-Mann gave them their name, borrowing it from a cryptic line in James Joyce's Finnegan's Wake, 3 quarks for muster mark. These quarks were bound together by the most powerful force known in nature, the strong nuclear force, carried by massless particles called gluons. Unlike the gentle pull of gravity or the far-reaching threads of electromagnetism, the strong force was different. It grew stronger as particles were pulled apart, ensuring that quarks could never be isolated. They lived forever in confinement, bound in groups, hidden from direct observation, like prisoners locked in a cosmic cell. And so, the standard model of particle physics was born. A framework that gathered the electron, the neutrino, the quark, and many others into a single family of fundamental building blocks. It described not only the particles themselves, but the invisible messengers, photons, gluons, W and Z bosons that carried the forces between them. Yet for all its power, the standard model was haunted by gaps. It explained much, but not all. It did not account for gravity, the oldest and most familiar of forces. It could not describe the dark matter that holds galaxies in their spiral forms, nor the dark energy that pushes the universe apart. What had begun with Thomson's electron and Rutherford's nucleus had grown into a cathedral of knowledge, intricate and astonishing. But it was incomplete. Like a map of an unseen land, it revealed only part of the territory. The search for what binds matter together, from Newton's gravity to Maxwell's fields to the hidden particles of the 20th century, had brought science to the threshold of revelation. The universe was no longer a machine of solid gears and wheels. It was a trembling web, woven from particles that flickered in and out of being, sustained by fields invisible yet omnipresent. And still the question lingered. What is the scaffolding that holds reality upright? The Standard Model gave answers, but left shadows. It described the pieces of the web, but not the loom that wove them. It gave humanity a glimpse of the hidden threads, and left the deeper mystery intact. The Standard Model stands as one of the most extraordinary achievements in human history. It describes with uncanny precision the invisible building blocks of nature, predicting the behavior of particles so ephemeral that they vanish before they can be named. It accounts for nearly everything visible in the universe, from the fire in the stars to the warmth of the human hand. And yet, in its perfection lies a paradox, for this elegant framework, so vast in scope, is also strangely fragile, incomplete, and haunted by unanswered questions. At the heart of its revelations lies a force unlike any other, the strong interaction. It is the most powerful force known to science, yet it operates only within the tiniest boundaries, binding quarks together inside protons and neutrons. Unlike gravity, which weakens with distance, or electromagnetism, which extends its influence. Across galaxies, the strong force grows stronger as particles are pulled apart. It is carried by particles called gluons, massless messengers that weave quarks into an unbreakable fabric. This discovery stunned physicists. The quarks that form the heart of every proton and neutron can never be set free, no matter how much energy is applied. Instead, they remain locked together, confined in triplets, like stars chained within a constellation that cannot be broken. Without the strong force, there would be no atoms, no chemistry, no stars, no life. The universe itself would collapse into a haze of unbound particles, unable to form structure. But this was only the beginning of the shock. The Standard Model revealed that the forces of nature are not transmitted through emptiness, but through invisible quantum fields, entities that extend everywhere, filling all of space. Every particle known to science is nothing more than an excitation, a ripple, a vibration within one of these fields. The electron, for instance, is a disturbance in the electron field. The photon is a wave in the electromagnetic field. Even the gluons themselves are threads vibrating in the gluon field. This was a revelation that overturned centuries of intuition. What appears solid is not composed of indivisible blocks, but of resonances within fields that no eye can see. Reality is not built of stone, but of song, a symphony of vibrations played upon a hidden stage that spans the cosmos. Yet questions rose as quickly as answers. Why do particles have mass at all? Why does the universe not dissolve into a chaos of weightless, drifting fields? The solution proposed in the 1960s was radical, an invisible field spread across the entire universe that endows particles with mass simply by their interaction with it. This became known as the Higgs field. Its associated particle, the Higgs boson, remained undetected for nearly half a century, a ghost within the equations of physics. When the Large Hadron Collider at CERN finally confirmed its existence in 2012, the scientific world erupted in celebration. Yet the triumph carried with it a deeper unease. For the Higgs mechanism explained why particles had mass, but not why the Higgs field itself exists. It appeared in the equations like a deus ex machina, necessary to hold the structure of reality together, yet without deeper explanation. Why should the universe contain such a field at all? Why should existence itself be calibrated so finely, balanced on invisible scaffolding that could just as easily have been absent? The more deeply physicists probed, the stranger the picture became. The Standard Model explained a universe of dazzling precision, but it was silent about some of the most profound mysteries. It could not incorporate gravity, the oldest and most pervasive of forces. It could not account for the dark matter that outweighs all visible matter by a factor of 5. It could not explain the dark energy that drives galaxies apart, accelerating the expansion of the universe into an uncertain future. The shock lay not only in what had been discovered, but in what remained unseen. The invisible web of particles and fields was real, confirmed by data and experiment. And yet, it seemed stitched with rules that no one fully understood. This raised questions that blurred the line between science and philosophy. If every atom is composed of particles bound by forces that are themselves invisible, what is the nature of solidity? What does it mean to say that something is real? The chair beneath one's weight, the stone beneath one's hand, the planet beneath one's feet, all are nothing more than shimmering constellations of fields, held together by forces that defy ordinary perception. Solidity is an illusion, a mirage born of quantum bonds. The human mind evolved to navigate a world of surfaces and shapes, of tangible forms and graspable objects. But the true foundation of that world lies far beneath, in a realm where particles vanish into waves and fields hum silently across space and time. To glimpse this reality is to see the universe stripped bare of its comforting disguises. In this light, the Standard Model is both revelation and riddle. It is a map of the hidden threads that hold reality together. Yet it ends abruptly at the edges of mystery. It has no place for gravity, no place for the unseen matter that sculpts galaxies, no place for the dark energy that dictates the fate of the cosmos. The shock is not only scientific, but existential. Humanity has uncovered the equations that govern the smallest scales of nature, yet those equations hint at a deeper, unfinished symphony. They whisper of forces beyond the known, of dimensions perhaps hidden, of patterns in the void that remain, concealed. The invisible web is real. Its threads have been measured, its particles detected, its fields confirmed. But to look upon it is to realize that the fabric of existence is not complete. The scaffold holds, yet the design remains unfinished, and so the mystery grows. If this is only the beginning, what lies beneath the web itself? The invisible web could not be seen with human eyes. To uncover its secrets, humanity built machines of extraordinary power, instruments vast enough to peer into the smallest domains of reality. In Switzerland and France, beneath the quiet fields, near Geneva, lies a circular tunnel 27 kilometers long. Buried in the earth like a colossal ring of steel, the Large Hadron Collider was designed to recreate conditions not seen since the first moments after the birth of the universe. Within it, protons are hurled close to the speed of light and smashed together with energies once found only in the hearts of stars. Detectors the size of cathedrals capture the debris, searching for whispers of particles that exist only for the briefest flicker of time. It was here, in 2012, that the Higgs boson was finally found. This elusive particle, proposed nearly half a century earlier, confirmed that mass itself is not an intrinsic property of matter, but a gift. Particles acquire their weight through interaction with an invisible field stretched across the entire universe, the Higgs field. Without it, the electron would be massless, unable to bind to atoms. Protons and neutrons would not form. Chemistry would never emerge. The universe would be a void of light and dust. The discovery was celebrated as a triumph, yet it carried a haunting undertone. For while it explained how matter holds form, it left unanswered why the Higgs field exists at all, why the universe is tuned so precisely, balanced on an invisible stage that might easily have been absent. The triumph of discovery only deepened the mystery. Beyond the Higgs, other phantoms roam the universe. Neutrinos, the little neutral ones, stream endlessly through all matter. Born in the nuclear furnaces of stars, in the radioactive decay of elements, and in the first seconds of creation itself, they flood the cosmos in unimaginable numbers. Every second, billions pass through each human body, through oceans, through planets, as though neither flesh nor stone could resist them. Nearly massless, with no electric charge, they slip through the universe like shadows that cannot be grasped. To detect them, scientists have carved observatories into mountains, submerged detectors in deep mines, and buried them beneath Antarctic ice. The Ice Cube Neutrino Observatory, a lattice of sensors frozen into a cubic kilometer of polar ice, listens for the rare flash of light created when a neutrino collides with an atom. In those fleeting sparks, humanity glimpses a particle that seems to belong more to the void than to matter itself. But the deeper scientists probed, the more they discovered nature's prisons. Quarks, the fundamental pieces of protons and neutrons, can never be isolated. The force that binds them, carried by gluons, grows stronger the more they are pulled apart, weaving an unbreakable cell. Even when smashed in colliders with titanic energy, quarks do not emerge alone. Instead, new particles form, bound again in triplets or pairs. This phenomenon, known as confinement, is unlike anything in the human world. It ensures that matter is never stripped of its scaffolding, that the foundations of reality are locked beyond reach. Patterns began to reveal themselves in this hidden world. Physics, at its core, is symmetry. The balance of forces, the mirroring of particles, the repetition of laws across time and space. Yet nature also breaks her own symmetries. The electron and the positron, equal and opposite, annihilate in perfect balance. But the universe itself leans ever so slightly toward matter, leaving stars and galaxies behind instead of dissolving into a bath of light. This imbalance, born from broken symmetry, is the reason anything exists at all. The closer science looked, the more fragile reality appeared. Quantum fluctuations, random tremors of energy in the void, suggested that even empty space is restless, never truly still. Virtual particles blink into existence, annihilating in moments, leaving behind only the faint imprint of their passing. The vacuum itself is alive, shimmering with unseen possibilities. And yet, for all the power of colliders and detectors, a deeper truth became impossible to ignore. All the particles and forces described by the Standard Model account for only 5% of the universe. The other 95% remains unseen. Galaxies rotate too quickly for their visible matter to hold them together. Something unseen, dark matter, binds them, outweighing stars 5-1. Its particles remain hidden, undetected, despite decades of searching. They do not glow. They do not scatter light. They slip silently through detectors, leaving only the trace of their gravitational pull on the cosmos. Beyond even this, the universe expands at an accelerating pace, driven by a force called dark energy. Its origin is unknown. Some imagine it as the pressure of the vacuum itself, a consequence of quantum fluctuations across cosmic scales. Others suggest it is a field unlike any we have yet discovered. Whatever it is, it dominates the fate of the universe, determining whether the cosmos will expand forever, tear itself apart, or collapse back into silence. The paradox was clear. Humanity had uncovered the most intricate details of quarks and leptons, mapped the forces that hold them, confirmed the Higgs boson, and glimpsed the neutrinos' flight. And yet the greater part of reality remained hidden. The invisible web described by the Standard Model was vast, but it was not the whole tapestry. Perhaps dark matter and dark energy are not separate at all, but deeper threads in the same web. Perhaps they are shadows of particles undiscovered, fields that stretch beyond the limits of known physics. Or perhaps they are signs of something stranger, that the very framework of the Standard Model is only a fragment, one chapter in a story far from complete. As instruments probe deeper, as colliders grow larger and detectors more sensitive, the universe answers with whispers and riddles. For every triumph of discovery, a greater silence remains. The invisible web is real, but its most important threads may still be hidden, waiting to be revealed by tools humanity has yet to imagine. The investigation deepens, and with it, the realization that the universe is not only stranger than we know, but perhaps stranger than we can know. In the Cathedral of Physics, the Standard Model stands as a triumph of human thought. It is elegant, precise, and astonishingly accurate, predicting the behavior of particles and forces with uncanny reliability. Yet, for all its brilliance, it is not whole. The model is a map missing continents, a symphony that halts just before its final movement. Its silence on one subject is deafening. Gravity, the oldest known force in the cosmos, the architect of planets, stars, and galaxies, is absent from this celebrated framework. Einstein's general relativity describes it as the curvature of space and time, a gentle bending of the cosmic fabric itself. But within the quantum language of the Standard Model, gravity has no particle, no field, no voice. It remains outside the structure, a ghost that refuses to be written into the equations. And beyond this silence lies an even greater mystery. For as astronomers extended their gaze into the night sky, measuring the movements of galaxies, they found a contradiction. What they saw did not match what they calculated. Stars at the edges of galaxies spun far too quickly, as though bound by a gravitational hand, stronger than visible matter could provide. Whole clusters of galaxies behaved as though filled with a hidden mass, unseen but undeniable. This enigma came to be known as dark matter. It does not shine, it does not burn, it does not interact with light, and yet it outweighs everything familiar. Roughly 5 times more abundant than ordinary matter, it sculpts the vast architecture of the cosmos. Without it, galaxies would scatter into dust, and stars would drift away like sparks from a dying fire. The hunt to identify it has spanned decades. Some imagine weakly interacting massive particles, WIMPs, heavy but elusive, whispering through matter almost without a trace. Others suggest axions, hypothetical particles born from subtle symmetries in quantum fields, as delicate as ripples in space itself. But despite the sensitivity of detectors buried deep beneath mountains and submerged in caverns of pure crystal, no definitive sign has yet been found. Dark matter remains a shadow, present only in its gravitational pull. If this puzzle were not enough, another revelation deepened the cosmic mystery. At the end of the 20th century, 2 teams of astronomers studied the light of distant supernova. They expected to see the expansion of the universe slowing down, dragged by the weight of gravity. Instead, they found acceleration. The universe was not just expanding, it was racing outward faster and faster, as if driven by an invisible wind. This discovery pointed to a force entirely new, a pressure embedded in the fabric of space itself. It came to be called dark energy. Unlike dark matter, which pulls and binds, dark energy pushes. It acts as a repulsive force, stretching the universe apart. Today, scientists estimate that nearly 70% of all cosmic content is composed of this strange energy. Matter, the very substance of stars, planets, and people, makes up less than 5. The implications are staggering. The cosmos is not dominated by what can be seen, but by what cannot. The atoms that form mountains, oceans, and life are a thin veneer on an abyss of hidden substance and unseen force. At the center of this revelation lies a paradox so severe it has been called the worst prediction in physics. According to quantum field theory, even empty space is not truly empty. It seethes with virtual particles, momentarily flickering into being before vanishing again. This restless activity should contribute a vast energy to the vacuum itself, an energy that Einstein once encoded in his equations as the cosmological constant. But when physicists attempted to calculate its value, they arrived at a number that overshot observation by 120 orders of magnitude. This is not merely an error, it is the greatest mismatch between theory and experiment ever recorded in science. Such a gulf suggests that something fundamental is missing. Perhaps dark energy is not a simple constant, but the effect of a hidden field permeating the universe. Perhaps it is tied to the fabric of space-time itself, woven into dimensions not yet perceived. Or perhaps it signals that the quantum and the cosmic, 2 towering pillars of physics, are fragments of a deeper unified law not yet glimpsed. Thus, the invisible web, once thought confined to the scale of atoms and particles, now reveals itself stretched across the horizon of the universe. It binds galaxies, fuels expansion, and shapes the destiny of everything that breathes and burns. It is no longer a whisper of the microscopic, but a chorus echoing through the infinite. This escalation of mystery leaves physicists in a state both of triumph and unease. They can predict the motions of quarks inside a proton with breathtaking accuracy. They can detect the birth cries of black holes colliding billions of light years away. Yet they cannot answer the simplest of questions. What is most of the universe made of? Why does the vacuum not collapse under the weight of its own energy? Why does gravity refuse to take its place beside the other forces? Reality, so solid to the human eye, is revealed as a fragile illusion. Atoms rest upon quantum fields. Fields rest upon symmetries, and symmetries themselves may be broken by unseen rules. Matter is but a faint glow within a darkness that defies comprehension. The invisible web is no longer a metaphor. It is the true architecture of the cosmos, a hidden lattice, veiled, incomplete, and waiting to be unveiled. And in that waiting lies the tension of science itself. Knowledge vast enough to map the birth of stars, yet fragile enough to confess ignorance before the greater whole. The web deepens, the mystery escalates, and the story of existence remains unfinished. The human quest to understand the hidden web of reality has always carried with it both triumph and incompleteness. With the Standard Model, science mapped much of the unseen lattice, particles, fields, and the forces that govern them. Yet, the silence of gravity, the enigma of dark matter, and the restless push of dark energy leave the picture fractured, like a mosaic with its center missing. And so, into this space of unknowing, theory has stepped. Ideas bold, daring, and often untested, seeking to extend the web to its true and final form. One of the most compelling is supersymmetry. It suggests that the familiar particles of the Standard Model, electrons, quarks, photons, are but half of a story. For each known particle, there may exist a hidden partner, a shadow twin that mirrors its properties in subtle ways. Fermions, the building blocks of matter, would be paired with bosons, the carriers of force. Every particle would find its reflection, balancing the equations of nature in a deeper symmetry. Such partners, if real, could solve long-standing puzzles. They might account for the unseen mass of dark matter, their ghostly presence shaping galaxies while escaping direct detection. They might stabilize the Higgs field itself, preventing the universe from collapsing into a lower state of energy. Supersymmetry paints a vision of a cosmos more elegant, more unified than what is observed. But despite decades of searching, at Fermilab, at CERN's Large Hadron Collider, and in laboratories around the world, no supersymmetric particle has yet appeared. The silence grows heavier with each passing year, leaving the question suspended. Is symmetry broken beyond repair, or does it lie just beyond the reach of human machines? Beyond supersymmetry, another theory dares to reimagine the very nature of particles themselves. String theory proposes that the smallest building blocks of reality are not points, but filaments, vibrating strings of energy. Each particle, from electron to photon, would be a different note played upon these strings. The universe itself becomes a grand instrument, weaving matter, force, and even space-time from the harmonics of vibration. In this vision, dimensions multiply. The familiar three of space and one of time may be only a surface. Hidden dimensions, curled tightly upon themselves, could ripple with unseen influence, determining the laws that govern the visible world. Gravity, so weak compared to the other forces, may appear faint because it seeps into these hidden realms, diluted across dimensions unseen. For some, string theory is the most promising path toward unification, a framework that might finally reconcile quantum mechanics with Einstein's relativity. For others, it is a cathedral of mathematics unanchored from experiment, a dazzling speculation not yet touched by evidence. But even in its uncertainty, it reflects humanity's deepest impulse, to imagine reality as more than what is visible, to weave a narrative where every particle is part of a deeper, more resonant song. Yet even without new dimensions or hidden strings, the very vacuum of space offers mysteries that defy comprehension. To the eye, emptiness appears barren, a void without structure. But quantum physics reveals it as restless and alive. Virtual particles constantly flicker into being, pairs of opposites that emerge from nothingness only to vanish again. This seething sea, invisible yet real, imparts forces that can be measured, as in the Casimir effect, where two uncharged plates in a vacuum are drawn together by the pressure of quantum fluctuations. The vacuum is not nothing, but a field of potential, a stage whose background hum may shape the destiny of the universe itself. It raises questions profound and unsettling. If emptiness is alive, then what is true nothingness? Is there even such a thing? Or is every silence in the cosmos, however vast, filled with the whispers of fields we cannot yet name? From this point, speculation widens further still. Some physicists suggest that our universe may not be singular, but one among countless others, a multiverse. Each universe could possess its own laws, its own values of mass, force, and symmetry. Some would collapse in instants, unable to sustain even the simplest structures. Others might give rise to stars, galaxies, and life. In this panorama, our cosmos would be but one pattern in an infinite tapestry, stitched among threads forever, beyond reach. The multiverse remains unproven, perhaps unprovable, yet it echoes in the mathematics of inflation, the theory that the early universe expanded with astonishing speed. In some versions of inflation, this expansion never entirely ends, creating endless bubbles of space-time, each bubble a universe, each universe a separate reality. If so, the invisible web that binds this cosmos may be one among innumerable webs, each distinct, each unknowable. But even within the boundaries of this universe, there lurks a possibility that chills the imagination. It is known as false vacuum, decay. The Higgs field, discovered in 2012 to give particles their mass, may not rest in the most stable configuration of reality. If the field occupies only a local minimum, a valley that is not the deepest, then at some point it could tunnel into a lower state. Such a collapse would ripple outward at the speed of light, altering the laws of physics in its wake. Atoms would dissolve, stars would extinguish, chemistry itself would unravel. The very web of existence would be torn apart and rewoven beyond recognition. Though calculations suggest such an event is unlikely for billions of years, the mere possibility underscores how fragile the fabric of reality might be. The solidity of existence, the assurance of matter, the constancy of forces, rests upon a balance that may not be eternal. Each of these theories, supersymmetry, string theory, quantum fluctuations, the multiverse, false vacuum decay, opens a door into deeper unknowns. Each provides a glimpse of a reality larger, stranger, and more intricate than the one that can be measured today. And yet, none offer closure. No theory has yet resolved the riddle of dark matter, the enigma of dark energy, or the silence of gravity. The web of reality remains veiled, its deepest strands hidden beyond human sight. Still, these speculations carry a profound message, that even in the absence of certainty, the act of imagining, of reaching beyond the visible, is itself part of the human story. Theories do not merely seek answers. They remind humanity that the universe is not fixed, not complete, but alive with possibility. The lattice of existence may stretch across dimensions unseen, resonate with strings beyond detection, or dissolve into new realities at any instant. It may be one web among infinite others, each distinct, each unknowable. What seems solid may be vibration. What seems empty may be alive. What seems eternal may be fragile. In this escalation of ideas, science does more than explain. It reflects the deepest human desire, to glimpse the hidden order, to trace the threads that bind galaxies, atoms, and life into a single fabric. And while each theory deepens the unknown, each also illuminates the wonder of the search itself. For it is within mystery that discovery takes root. And in the speculation of physicists, the cosmos reveals not just what it is, but how endlessly more it might be. To glimpse the invisible threads of reality, humanity has built instruments that rival myth in both scale and ambition. Vast machines lie buried beneath mountains, frozen into polar ice, or stretched across continents. Each one is a kind of sense organ, extending human perception beyond its natural reach, straining to feel the faint vibrations of the hidden web. At the heart of Europe, near Geneva, lies the most powerful of these creations, the Large Hadron Collider, a 27-kilometer ring buried beneath the soil of Switzerland and France. It is a tunnel where protons are accelerated to near the speed of light, then smashed together with violent precision. From these collisions, the invisible is coaxed into being. Particles that last for only an instant, resonances that vanish almost as soon as they appear, each one a fleeting ripple on the quantum fabric. In 2012, this colossal machine revealed the Higgs boson, the particle tied to the field that grants mass to the building blocks of matter. It was a triumph, a confirmation that the invisible web does not merely hold reality together, but breathes mass into what would otherwise remain weightless shadows. And yet, discovery did not close the book. The collider now hunts deeper, searching for supersymmetric partners that may never exist, probing the Higgs itself for signs of cracks in its stability. Every upgrade pushes further, demanding higher energies and sharper detectors. It is as though humanity is tuning its machines to hear whispers softer than silence itself. Beneath the ice of Antarctica, another kind of instrument lies hidden. The IceCube Neutrino Observatory is not a collider, but a listener. Strings of detectors sink deep into the transparent ice, waiting for the faintest flashes of light created when neutrinos, ghost particles, brush against atoms. Billions pass through every person each second, indifferent, silent, almost massless. Yet IceCube has caught them arriving from the farthest reaches of the cosmos. From supernovae, black holes, and active galaxies, whose jets hurl matter across millions of light years. These neutrinos carry with them messages unaltered by dust or magnetism, straight from the heart of cosmic violence. They are threads of the web that pass through all matter without pause, reminders that the universe's scaffolding extends into dimensions of energy that ordinary senses cannot perceive. In caverns beneath mountains, in Italy, Japan, Canada, and the United States, other neutrino experiments seek to pin down their elusive properties. Do neutrinos have mass because of the Higgs field, or through some other mechanism unknown? Do they oscillate between identities because of hidden forces, hinting at another layer in the structure of the web? Each answer could reshape the standard model, opening doors to realms not yet imagined. The search does not end with particles. Across the Earth, instruments listen not for matter, but for the trembling of space-time itself. The Laser Interferometer, Gravitational Wave Observatory, LIGO, with its twin detectors in Washington and Louisiana, has stretched beams of light across 4-kilometer arms to measure shifts smaller than a fraction of a proton's width. In 2015, it succeeded. 2 black holes collided more than 1 billion light-years away, sending ripples through space-time that LIGO caught upon its mirrors. The web of reality does not merely bind particles, it vibrates with the weight of merging stars. Virgo in Italy and Cagra beneath Japan's mountains now join the network, each one sharpening humanity's hearing of the universe's deepest bass notes. Future observatories, like LISA in space, will extend the reach, detecting waves from sources even more ancient, perhaps even echoes of the Big Bang itself. While these detectors sense the universe's vast tremors, new eyes have been turned toward its faintest light. The James Webb Space Telescope, stationed 1 million miles from Earth, peers through infrared wavelengths to glimpse galaxies that formed in the dawn of time. Its mirrors catch light stretched thin by the expansion of the universe, offering not only images, but maps of matter, both seen and unseen. Dark matter, though invisible, sculpts galaxies into spirals, bends the paths of light, and leaves fingerprints on the cosmic web. Webb, along with upcoming missions like Euclid and the Vera C. Rubin Observatory, searches for these imprints, hoping to chart the shadow architecture that holds the cosmos together. Every distorted arc of light, every subtle deviation in cosmic structure may point toward the particles that constitute this unseen glue. On scales far smaller, laboratories attempt something equally ambitious to probe the very vacuum itself. Atom interferometers, experiments where the wave nature of atoms is split and recombined, measure with exquisite precision how quantum fields shift in emptiness. Even the faintest fluctuations of the vacuum, or hidden forces coupling to matter, could bend their results. Quantum simulators, built from ultra-cold atoms and controlled with lasers, attempt to recreate miniature universes, where new physics can be tested in controlled form. Each one is a model, a mirror of reality, in which the invisible rules of the web may reveal themselves in ways the cosmos does not permit to be directly observed. All of these tools, the colliders, the neutrino observatories, the gravitational wave detectors, the telescopes, the quantum machines, together form a network of human ingenuity spread across the planet and into space. They are colossal extensions of human perception, machines the size of mountains and as delicate as thought itself. Their purpose is singular: to press against the unseen fabric of the universe until it trembles, until the hidden web gives up one more secret. And yet, even with these instruments, much remains untouched. Dark matter continues to slip through, detectors in silence. Supersymmetric particles remain absent in the debris of collisions. The Higgs boson behaves as expected, revealing no fracture that might lead to deeper law. The vacuum, restless though it is, refuses to yield the explanation for dark energy's accelerating push. It is a strange paradox. The greater the precision, the more silent the unknown becomes. Each instrument, no matter how vast, measures only echoes and shadows. The web is there, the universe could not exist without it, but its deepest threads evade every grasp. Still, the pursuit continues, because each attempt, even in failure, draws the boundary of human knowledge further outward. Each unanswered question refines the next instrument. Each silence deepens the imagination. Science does not only seek to measure, it learns to listen more carefully with each passing generation. In the end, these tools are more than machines. They are monuments to wonder, carved not of stone, but of magnets, mirrors, and light. They are the embodiment of a species that refuses to accept the visible as the whole. Through them, humanity stretches its senses beyond the earth, into the void, and onto the hidden lattice where matter, force, and existence are bound together. It is through these colossal instruments that the invisible web is slowly traced, not in full, not yet, but in fragments, like faint strands illuminated in the dark by a passing beam. The task may take centuries, the answers may remain elusive, but as long as these tools are built, the search continues, and the unseen fabric of the cosmos is pressed against, probed, and revealed one trembling thread at a time. Every object, every motion, every living breath exists only because of threads too fine for eyes to see. The solidity of a mountain, the weight of the sea, the warmth of a flame. None of these are truly solid or eternal. They are patterns, sustained by fields, forces, and particles that flicker in and out of being, stitched together by a lattice that cannot be touched. To stand before a stone wall is to face a mirage. Atoms separated by vast distances relative to their size give the illusion of hardness only because electrons refuse to collapse upon one another, held apart by electromagnetic fields. The ground beneath a foot is not solid, but a symphony of repulsion, particles pushing back with invisible hands. What feels firm is only resistance. What feels permanent is only balance. Human beings themselves are woven shadows of this same architecture. The iron in blood was forged in dying stars, the carbon in flesh, born in the collapse of stellar cores, the oxygen in lungs, the legacy of galaxies that burned long before Earth existed. But even these elements are not substance in the way imagination suggests. They are dances of quarks bound by gluons, masses granted by the Higgs field, energies trapped in fleeting arrangements. Life is not carved from matter. It is assembled from whispers of fields, momentary gatherings of the invisible web. In this way, existence itself becomes a loom. Every instant, particles bind and separate, threads stretch and snap, forces balance and collapse. The universe is not a fixed sculpture, but a tapestry in motion, weaving itself anew with each fraction of time. From galaxies spiraling in silence to a single synapse sparking in the human brain, every detail is part of this cosmic weaving. The loom never rests, and yet no hand directs it. The design is emergent, the pattern an accident of laws so delicate that their very existence seems improbable. Consider the fragility of it all. If the strong nuclear force was slightly weaker, atoms would fall apart and stars could never ignite. If it were slightly stronger, hydrogen would vanish in a heartbeat and the universe would collapse into heaviness. If the Higgs field's value shifted even slightly, mass would dissolve and chemistry would never unfold. Existence, in its grandeur, hangs on a balance so fine it is as though the loom were tuned to an impossible harmony. And yet, the harmony is real. The cosmos hums with unseen vibrations, a background music carried not by sound but by fields. Every particle resonates with this music, every force an echo of the deeper fabric. The human body is not separate from it, but part of the same symphony. A temporary arrangement of chords struck upon the strings of matter and energy. The illusion of solidity hides a more profound truth. All things are ephemeral. Atoms that compose a living being now will drift elsewhere in the future, folded into soil, sea, or star. What feels like permanence is only a pause, a fleeting configuration held together for a moment by the invisible lattice. To be alive is to exist within this pause, to move for an instant upon the threads of reality before dispersing into the greater weave. The universe itself is no different. Galaxies are not eternal islands, but transient storms of stars, forming, colliding, dissolving back into the cosmic sea. Even space-time may not be permanent. It too may unravel or transform, just as the Higgs field could collapse or the vacuum could shift. The web that holds reality together may one day break, and a new loom may begin. But within that fragility lies a kind of majesty. It is precisely because the threads are unseen and delicate that existence appears so luminous. Every sunrise, every breath of wind, every quiet thought is the flowering of a lattice that could have been otherwise, a structure built on uncertainty, yet unfolding with precision. The cosmos offers not solidity, but wonder, not certainty, but mystery. And so the question rises, unanswerable yet inescapable. If the invisible web is the foundation, what lies beyond it? What deeper architecture gives birth to these fields, these particles, this trembling fabric that sustains reality? Is there a deeper loom, a more hidden symmetry, a silence beneath the silence itself? Perhaps the answer will never be known. Perhaps the greatest gift of the universe is not resolution, but the invitation to wonder, the endless horizon of possibility. For even without knowing, humanity has already glimpsed enough to be humbled. That everything seen is not what it seems, that every surface is woven of ghosts, that every moment rests on the balance of invisible threads. In the end, the silence of the void is not empty, it sings with hidden vibrations. It hums with fields that stretch across galaxies, with particles that flit through matter like shadows, with energies that shape the very geometry of space and time. The cosmos is not held by stone or by steel. It is held by silence that trembles, by invisibility that sustains, by threads finer than light. And in that silence, in that unseen song, reality itself endures. The story ends where it began, in silence. But now the silence is no longer empty. It carries the weight of hidden particles, the resonance of invisible fields, the delicate tremor of threads that hold all things together. From the heart of Colliding stars to the stillness of a human thought, everything rests on this unseen foundation. A cosmos that appears solid, yet is woven from shadows. A universe that feels eternal, yet is only a fleeting vibration in the deeper fabric of time. And so the search continues. Telescopes stretch their mirrors toward the night. Detectors wait, patiently in the dark, and equations unfold like ancient maps, all striving to touch what cannot be touched, to measure what cannot be seen, to hear the song beneath the silence. For in that hidden music lies not only the story of galaxies and particles, but the story of ourselves, fragile patterns of matter, briefly luminous, suspended on invisible threads. The web of reality endures, and though it cannot be seen, it can be felt every time the universe breathes.